Arithmetic sequences and series. Probably the simplest way to generate a sequence is to start with a number and add to it a fixed constant over and over. Such a sequence is going to be called an arithmetic sequence and is given by the following, as just described. So you start with a number and you keep adding to it a fixed constant, in this case labeled as d, over and over. That d is called the common difference of the sequence. It's called a common difference because any two consecutive terms differ by this number d, right? So to move from one term to the next, you just add d. And in general, the nth term of an arithmetic sequence is given by this recipe. So you start at a, and to get to the nth term, you add n minus 1 times d, correct? So to get from the first term to the third term, you add 2d, right? So you get 1d to get to the first and another d to get to the second. So what this is saying is, to get to the nth term, we add to the first term, which is a, n minus 1 times d, right? So to get from the first term to the nth term, you add n minus 1 times the d. Okay? All right. So this comment has to do with the the phrase common difference, and we just explain why. Example 1, part 1. If a is 2 and d is 3, then we have the arithmetic sequence the following. So you start with 2 and you add 3, right? So you add 3 to get to the next one, which is 2 plus 3. And then you add twice the 3, so twice the d, twice the common difference, to get to the third term. And you add to 2 3 times that common difference, you get to the fourth term, and so on and so forth. So you are generating a sequence that looks like this: 2, 5, 8, 11, and so on. Okay? Any two consecutive terms of the sequence differ by this number 3, and the nth term is given by 2 plus n minus 1 times the d. So n minus 1 times the 3, because d is 3 in this case. Okay. For example, let's say the ninth term. What's the ninth term? This is when n is 9, right? So a9, which is the ninth term, which is 5 more terms, right? 5 more terms to this. So a9 is 2 plus 3 times 9 minus 1. 9 minus 1 is 8. 8 times 3 is 24. 24 plus 2 is 26. So the ninth term is 26. If you keep writing these elements, if you go to the ninth term by adding 3 each time, right? By adding 3 each time. So the next one here would be 14. Following one is 17, then 20, then 23, and then 26. And this is the ninth term, right? So 1, 2, 3, 4, 5, 6, 7, 8, ninth term. Make sense? All right, so let's erase this part. And let's move on to the next example, part 2 of the example. Consider the arithmetic sequence 9, 4, minus 1. So what's going on here? We're subtracting by 5 each from one term to the next. Okay, so the common difference is minus 5. So you're gonna realize that the terms of such an arithmetic sequence are gonna be decreasing. So they're gonna be decreasing, and this happens whenever we are considering this common difference to be negative, right? Because we are chipping away a certain number of units from one term to the next. All right, so for this sequence, the nth term would be the first term, which is 9, plus n minus 1 times the d, but the d is negative 5 here, so it would be minus 5 times n minus 1. The third part of this example is the following. The graph of the following arithmetic sequence, that one, is shown below. For example, the first term is when n is 1, so that guy would be 0, and as such the first term is 1, so a1 is 1. The second term, when n is 2, this would be 1 times 2 plus 1, so this would be 3, and so on. And you're gonna realize that all these guys, they're gonna belong to the graph of the function f of x equals 2x minus 1, right? So look, if you simplify this, how would you write this? Isn't that one as 2n minus 2 plus 1? Can't you rewrite this as such? And 2n minus 2 plus 1, isn't it 2n minus 1? Correct? So the ANs, as we talked about in the previous section, the ANs, the terms of the sequence, can be thought of as the image under a certain function of these numbers n, of these positive integers n. Correct? So that's the corresponding function that produces those outputs ANs if you plug in this function just positive integers. Correct? If you plug in 1, you're going to get A1. If you plug in 2, you're going to get A2. If you plug in n, you're going to get the ANth term, right? So the AN, which is the nth term. Make sense? So what I'm saying is that all these points belong to the graph of this function f of x, which is a line, right? And having slope 2, and 2 happens to be that d, the difference, the common difference. Make sense? Okay. All right, here's an example. Find the first 6 terms and the 300th term of the following arithmetic sequence: 13, 7, and so on. So they told us that this sequence is arithmetic, right? Which means the nth term is given by the first plus adding n minus 1 times the common difference. Make sense? So this is the recipe of the nth term. Okay, and this is for any n natural number. Okay. All right, so what did they tell us? We want to find the first 6 terms and the 300th term. Well, what's A and what's D in this context? A is 13, it's the first term, right? A is 13, so this guy is 13. And how much is D? D is the common difference. They told us arithmetic, so we're gonna keep going with the same pattern by chipping away that number that's in this case 6, right? So we are subtracting by 6 to move to the next term. So D in this context is negative 6. Make sense? Okay. So what can you say then? AN in this context is 13 plus minus, right, because D is negative 6, minus 6 and minus 1. Correct? So the first 6 terms are the first one is 13, it's given to us. The second one is 7. You keep subtracting by 6. So 7 minus 6 is gonna be 1. You can check it here. The third term is when n is 3, right? 3 minus 1 is 2. 2 times 6 is 12. 13 minus 12 is 1. Correct? And you keep subtracting by this number 6. You're gonna get minus 5, minus 11. So how many have we generated so far? 1, 2, 3, 4, 5, one more. So minus 17. Correct? So these are the first 6 terms. 13, 7, 1, negative 5, negative 11, and negative 17. Now they said, okay, I want to also find the 300th term, which is A sub 300. Obviously, I'm not going to just keep add or subtracting 6 over and over to get to the 300th term. What I'm going to do is I'm going to just use this formula over here, right? So let me box it. I'm going to obviously use this to find the nth term, because this formula holds for all n, right? For all n. This is the general recipe of the nth term of the sequence, and this is for any n. Well, if you want the 300th term, take the recipe and replace n by 300, and you get 13 minus 6 times 300 minus 1. Okay, and 300 minus 1 is 299. So 30 minus 6 times 299. And if you do the math, this is minus 1781. Okay, so the term of rank 300 in that sequence, in this arithmetic sequence, is minus 1781. So minus 1781. Example 3. So actually in the previous example they gave us the first two terms and we were able to find the nth term, the recipe of the nth term. In that case they asked us to find the term whose rank is 300. In this case, in this example, they're gonna give us the 11th term and the 19th term of an arithmetic sequence, and they're gonna tell us to find the term whose rank in this case is 1000. So out of this we can say that an arithmetic sequence is completely determined by two of its terms. So if you know two of its terms, they don't have to be the first two like in the previous example. Any two of its terms can allow us to find all the others. Okay, so it's completely determined by any two of its terms. Alright, so in this case they gave us the 11th term. So A11, they told us that it's 52, right? It's 52. And they told us that the 19th term is 92. Correct? This is what they told us. And the question is, we want to find a sub 1000. Correct? So we want to find the term whose rank is 1000. All right. So since it's an arithmetic sequence, what can we say? We know that the general term an is the first plus n minus 1 times the common difference, right? We know this. This is for any n. So when n is 11, I'm gonna get a11, right? And a11 is gonna be a plus 11 minus 1 d. Correct? So if you call this, let's give this a name. How about asterisk? So from asterisk, I'm gonna be able to say that this is equal to, because I'm talking about a11, right? When n is 11, it's gonna be a plus n minus 1, so 11 minus 1 times d. Correct? If I'm able to find a and d, I'm able to give in this case the term whose rank is 1000. So the idea is to find a and d. These are the two ingredients to find the general term of an arithmetic sequence. So I'm trying to find them. I'm trying to get to the point where I can reveal what they are in this context. All right, A11, so the 11th term of the sequence, I know on one hand it's 52. On the other hand, it's given by this recipe when n is 11. So I wrote that. So these two must be the same then. 52 must be a plus, this is 10, d. And a19, when n is 19, I get a19. And this is equal to, this is also by asterisk, right? This is also by asterisk. I get that this is equal to what? This is when a is 19. When n is 19, I get a plus 19 minus 1 times d. Correct? So let me highlight the two things that are important. So 52 is equal to that at the end of the day. Why? Because 52 is equal to a11, and on the other hand, a11 is equal to this by asterisk. And also 92, which is equal to a19, a19 on the other hand, because of asterisk, is equal to this. So what can we infer? We infer that this must be 92. Make sense? Let me color them in different color just because I'm equating I'm equating those guys, so let me just use the same color for them. So the blues are the same, and these two guys are the same, correct? Thus, a plus, again, 11 minus 1 is 11 minus 1 is 10, right? So this is 10, and 19 minus 1 is 18. So thus, we get that a plus 10d is equal to 52, and a plus 18d is equal to 92, correct? So this is a system of two variables, a linear system in two variables, so that's easy to be solved. How about we solve for a in the first equation and replace that value or that expression of a in the second equation. So that first equation, that's equivalent to saying that a is 52 minus 10d, correct? So the first equation tells us that a is 52 minus 10d, and now that's the same a, so you can take that expression in terms of d, replace it here, and get an equation just in d, which is easy to be solved. Okay, so take this value of a, replace it over here, correct? So take this value of a, replace it over here. The second equation becomes an equation in one variable, which is d. So 52 minus 10d plus 18d must be 92, right? Again, what did I do? I took this expression of a, 52 minus 10d is a, replace it here, and you get the second equation as such. This is a linear equation in one variable, which is d, so we can solve it. All right, if we solve this, what do we get? This is 52 plus 8d is equal to 92, correct? Why? Because 18d minus 10d is 8d, and this is the same as 8d. If you subtract by 52, 8d is 40, which means d is 5, right? So d is 5. All right, so I know what d is then at this point. That's d. How about a? Well, a is 52 minus 10d, and you know what d is. So what is a? Then a, which is 52 minus 10d, is equal to 52 minus 10 times 5, because I know at this point that d is 5, so I'm using this result. I'm using this result right here, correct? Because I know that d is 5. So this becomes 10 times 5. And this is how much? This is 52 minus 50, which is simply 2, correct? So a is 2. So a is 2. So d is 5 and a is 2. So we can rewrite this where a, I know what a is in my context, and I know what d is in my context. So it follows that. The arithmetic sequence of this context is given by an equals, I'm replacing a by 2 and d by 5. So it's given by an equals 2 plus n minus 1 times 5. And this is for any n bigger than or equal to 1, correct? For any n bigger than or equal to 1. All right, and what did they want? They want the term whose rank is 1000. So they want a sub 1000. So they want a sub 1000. So therefore, a sub 1000 is equal to 2 plus, I'm replacing n by 1000, so 2 plus 1000 minus 1 times 5. Okay, and if you do this, that's gonna be, this is so 1000 minus 1, that's 5000 minus 5, which is 4995 plus 2, so that's gonna be 4997. Okay, that's what a 1000 is. Make sense? All right, let's have the following discussion now. Suppose we want to find the sum of the first 100 natural numbers, so the sum of the first positive integers, 100 positive integers, 1, 2, 3, 4, 5, etc., all the way to 100. That is, I want to find this guy. Remember this, the summation notation? So I want to find the sum of terms that look like k, but k ranges from 1 to 100. So this is 1 plus 2 plus 3 plus 4, etc., all the way to 100. So technically what I'm saying is that this is the 100th partial sum, right? Remember, the nth partial sum is the sum of the first n terms of the sequence. So that's the sum of the first 100 terms of that sequence, 1, 2, 3, 4, etc. This is certainly an arithmetic sequence because the first term is 1 and the difference, the common difference is also 1, right? So that's nothing but the 100th and the 100th partial sum, and let's give it a name as sub 100. Okay, so we want to find what this sum is equal to. Let's approach it this way. Well, S100, which is the sum of the first 100 terms, so it's going to be 1 plus 2 plus 3 plus 4, etc., all the way to 100, so 98, 99, and 100. Correct? How about we write the same thing but in a reversed order? If you write it in a reversed order, you're going to get 100 plus 99, plus 99 plus 98 plus 97 all the way to 3, 2, 1, correct? So you get this. How about now we add these two? By adding, I mean I'm adding both sides of this of these equations. So we're adding these two. What do we get? Well, we get that this is equal to twice s sub 100 on this side, right? Because s sub 100 times plus itself is twice the thing, equals 1 plus 100. I can look at these as, I can look at the sum of the, all the guys upstairs plus the sum of all the guys downstairs. I can look two at a time, right? 1 plus 100 is 101. 2 plus 99 is 101. 3 plus 98 is also 101. 4 plus 97 is also 101, and so on. Correct? This is 101. This is also 101. And the last one, which is 100 plus 1, is also 101. And how many 101s do we have? How many of these guys? 100 times, right? 100 times. Because I have the same number here, the same number of summands is, that number of summands is the same as the number of summands in any of these two expressions, right? So the number here is 100. Okay, so what can we say then? So two times that number that I want to find is equal to 100 times that 101, correct? 100 times that 101. 101 plus itself 100 times is 100 times 101, right? So they are the same then, which means that number that I want as sub 100, that sum, is, if I divide both sides by 2, I get 50 times 101. 50 times 101, correct? And this is how much? You can think about 50 times 101 as 50 times 100, so 5,000 plus 50, right? Plus 5, 50 times 1, so it's 50, 50, correct? 5,050. Anyway, so that sum is 5,050. Well, this approach is way easier than just adding those number in a naive way, right? 1 plus 2 plus 3 in a naive way to get that number. Okay, and this approach is not due to me, obviously. It's due to the famous mathematician Carl Gauss. Okay, so this approach is due to Gauss. And that dates back to his when he was a youngster, when he was a schoolboy. His teacher actually posed this question to the class, and he came. I mean, the teacher thought it's gonna keep the students busy for a long time, but Gauss answered the question almost immediately. Okay, and his approach was this one. So what we're gonna do now is we're gonna use his approach to actually generalize to find the sum of the first n terms of any arithmetic sequence, because this guy is an arithmetic sequence, but it's a particular one, correct? It's a very particular arithmetic sequence. We're gonna take this approach and try to transplant it into the more abstract context. So for any given arithmetic sequence, we're gonna try to find the first n terms of such a sequence. Okay. So let's do that. So let's say we wanna find the sum of the first n terms of the arithmetic sequence whose terms are given by the following. So a sub I is equal to a plus I minus 1 times d, right? This is the formula for the general term of the arithmetic sequence, and this is for all I bigger than or equal to 1, correct? So this is an I here. Okay, so what we want to do is we want to find Sn, which denotes the first, the sum of the first n terms. So the first term is a, the second term is a plus d, right? The third term is a plus twice d, and so on. So a plus 3d plus dot 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 all the way to the last one. Let's write the second to last. What's the second to last? So if the last one is here, I'm gonna have n minus 1, right? The last one is an. The previous one is gonna be where I'm gonna have here n minus 2, correct? So that's gonna be a plus n minus 2d, and now the last one is a plus n minus 1d. Make sense? So that's the n minus first term, and that's the nth term. Okay. All right. So as we said, we're gonna employ Gauss' idea. So we're gonna rewrite that as n but backwards, right? So we're gonna write this same as n but backwards. So we're gonna have the last one of the first expression to start with. So a plus n minus 1d plus the previous, so a plus n minus 2d plus dot 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 all the way to, let's write the last, let's say 3 terms. So I'm gonna have a plus 2d plus a plus 1d plus a, right? Correct? And now if you add them, so now we're adding, what do we get? Keep in mind how we keep in mind the model that we had before, right? How we handled this case. We're gonna handle it the same way. It's the same model, but here we don't have specific numbers anymore. Okay, so let's take a look. So on the left side, I'm gonna have Sn plus Sn exactly as I had S100 plus S100, so twice S100 at the time, right? So here twice Sn. So this side is gonna produce twice Sn. And how about this side? Well, as we said, we're gonna add them in a vertical way in some sense. So we're gonna add the first term here to the first term here, right? Who's the first term upstairs? It's the A. Who's the first term downstairs? It's this guy. So if you add those two, we obtain what's A plus that guy. It's A plus A, so 2A. So 2A plus n minus 1 times d. Correct? Okay. Now we're going to add the second term here to the second term here. Let's do it. So we're adding this to this, right? And what's that? This is a plus d plus a plus n minus 2d. Well, a plus a is 2a. And n minus 2 copies of d plus one more copy, I get n minus 1 copy of d. Correct? And so on and so forth. And so on and so forth. Let's add the last two. Let's take a look at the last two. So we're talking about this added to this, right? And if you add this to this, how much do we get? We get still 2a plus n minus 1d. And the last one, we're adding a plus n minus 1d to a. That's going to give us still 2a plus n minus 1d. Correct? So thanks to Gauss approach, I was able, that approach actually applies to the abstract case. It doesn't only apply to what his teacher gave him to handle. All right, and this is what? How many copies of this package do I have? If you think about as this one package, it's the same package over and over, right? How many of these packages do we have? Well, how many summands did we have here? We had, how many summands? We had n summands, right? So 1, 2, 3, all the way to the last one, which is the nth one, correct? Because Sn is the sum of the first n terms. So the number of summands is n, and the number of summands here is also n. It's the same number. We just reverse the order. And then we added the first togethers and the ith together. And then what do we get? How many summands? This is also n, correct? So this is also n summands. As such, we get 2 times Sn, which is the left side, is equal to n times this package, right? N times this package. Do you agree with me? Again, I have n copies of the same package added together. You get n times that package. Okay? So n times, right? Very good. And then this is the same as saying that Sn is equal to n over 2 times 2a plus n minus 1d. So the sum of the first n terms is nothing but this expression, correct? In the previous context, a was 1 and d was 1, and we were talking about s sub 100, right? So we were talking in the previous context I'm talking about. So this was 100, and a was 1, and d was 1, right? And this was 100. If you do the math here, you're going to get 99 times 1, which is 99, plus 2, which is 101, and this is 50. So that's the same expression we got, 50 times 100, if you remember. 101, right? 50 times 101. Okay? So this is the sum of the first n terms of any arithmetic sequence. So this is the general formula, right? It encompasses what Gauss discovered in the earlier example. But his idea is applicable to the abstract case. All right, very good. Now, let's rewrite this in a slightly different fashion. Let's write it as follows. This is the same as n over 2 times a plus a. I can think about 2a as a plus n minus 1 times d, correct? And what is this? What's this guy? Isn't it an? Isn't a plus n minus 1 d the nth term of the arithmetic sequence? So what can we say then? This is equal to n over 2, or let me write it this way, n times a plus an over 2. Correct? So that's the a plus an divided by 2. So this last formula, how can you read it? So the sum of the first n terms of an arithmetic sequence, labeled here by Sn, is the average of the first and nth term. This is the first and nth term, right? Let me label it for you. So this is the first term, and this guy is the nth term, right, of the arithmetic sequence. So one more time. The sum of the first n terms of an arithmetic sequence is the average, right? It's the arithmetic average, meaning the sum divided by 2 here, because I have two entities, of the first term and the nth term multiplied by n. And what's n? It's the number of terms we're adding, right? It's the number of terms we're adding. So the number of terms and the sum. So you get this nice property. The sum of the first n terms of an arithmetic sequence is the average between the first term and the nth term multiplied by the number of terms in the sum. Okay, so let's record this. Let's record it. Here it is. So that's the property we're talking about. Let's read it. For the arithmetic sequence an, which is given by this general recipe for the nth term, the nth partial sum labeled by S sub n is given by any of these two formulas, right? This is a property we found above, and we rewrote it as such. Okay? All right. Example 4. Find the sum of the first 40 terms of the arithmetic sequence 3, 7, 11, 15. So here we want to find S sub 40, the sum of the first 40 terms. And let's use any of the two, they're the same. So keep in mind, this property holds as long as we're talking about arithmetic sequence, right? If the sequence is not arithmetic, you cannot apply this. I'm talking always, let me actually underline this for you so you don't confuse it with any other things. So we're only talking about arithmetic sequences in this property, okay? And this is arithmetic. All right, so S40, which is the sum of the first 40 terms, or we used also the terminology, the 40th partial sum, right? Okay, is equal to, which one do we want to use? Use both at home. I'm going to use, let's say, this one. So it's n, which is 40 in this case. N is the number of summands, right? The number of terms, divided by 2 times who's a? Who's a? A is the first term. That's a, right? A is the first term, which is 3. and I also need d. Who's d? D is the difference, the common difference, which is 4, right? I'm adding 4 each time. All right, so 2a, so 2 times 3 plus n is 40 minus 1 times d, which is 4. Correct? So it's an application. You just apply it. You don't. I mean, it's way simpler than the proof of it, obviously. So you just replace n by the appropriate choice, which is 40 in this case, and a, which is the first term, and d is the common difference. You just add that. This is what? This is what? This is 20 times 6, right? This is 6 plus 40 minus 1 times 4. So this is 160 minus 4, so 156. Okay? And you figure out what this thing is. So this is 162 times 20, so 3,240, right? Makes sense? Anyway, so that's easier than adding them by hand, correct? So you apply it, you get it. Okay. Next, find the sum of the first 50 odd numbers. So the sequence of odd numbers is an arithmetic sequence, correct? It starts at 1. It keeps going. So 3 is the next, 5 is the third, and so on and so forth. Correct? So the first term is a, which is 1. The common difference is 2, right? So from one odd to the next, you just add 2. Correct? And then the nth term is going to be given because it's arithmetic. Each one is 2 units away from the previous and 2 units away from the next. So an is going to be a plus n minus 1 times d, where in this context I know what a is and I know what d is, right? I know that a is 1 and I know that d is 2. Oops. Correct? So what's a 50? They want the sum of the first 50 odd numbers. What's a 50 then? Well, a 50 is going to be a, which is 1. So this is implied by the discussion above. So a 50 is a, which is 1, plus n minus 1. If n is 50, that's going to be 50 minus 1 times d. And how much is d in our context? Is the common difference, which is 2. Okay. And how much is this number? This is 1 plus 49 times 2. Correct? And what is that? Isn't that 99? This is 99. So if what they're saying here is that if you keep going, you have to stop at 99. You have to stop at 99 and add them up. And add them up. Make sense? Alright. And this makes sense to stop at 99 because half of the first 100 integers, positive integers, are even and the other half are odd, right? So anyway, so then S50, which is the sum of the first 50 odd numbers. So this is 1 plus 3 plus 5 plus 7 plus dot 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 plus 97 plus 99, right? Because the previous one is 97. That sum turns out to be, based on the formula that we developed, based on this formula, okay, based on this formula. How about I copy it and use it below? So based on this formula, okay, just color that. So we're using this Sn equals that with Remember what n was? N was the number of terms. How many terms do we have? It's 50. So with n equals 50, so I'm using this, with n equals 50, and who's a? A is the first term, and I know what the first term is, 1, right? It's the first term in that sum, 1, and an is gonna be the 50th term in this arithmetic sequence, which is 99. Correct? So that's my package. That's my package here. And that's what I'm going to be needing. Now what do I get? So I get n, which is 50, times the average between two numbers. The first is the first term of the sequence, which is 1, plus the 50th term of the sequence in this case, which is 99. Okay. And how much is this? 50 times 50. Correct? Because this is 100 over 2, which is 50. 50 times 50 is 2500. So the sum of the first 50 odd numbers is 2500. Okay. All right. Example 6. The question here is, how many terms of the arithmetic sequence 5, 7, 9, and so on? So this is like a subsequence of the sequence we just talked about, the sequence of odd numbers. So how much should we add, how many terms of the sequence to get 572? Okay, and the assumption is you're gonna add starting from the first term. So how much of those, how many terms should we add to get to that number, 572? Okay. All right, so here the question is, what should n be, right? N being the number of summand. So how many terms should we add so that the nth partial sum becomes 572? This is the question, right? So we want to find n. That's the desired thing. I want to find n so that the nth partial sum is 572. Okay? Let's go back to the formula for the sum of the first n terms of any arithmetic sequence. It's this one, right? It's this one. I'm going to take it with me and paste it below. So let's paste it here. And let's give it a different color, about blue. All right, so I'm going to use this because this is the sum of the first n terms of any arithmetic sequence. And in this case, I have, this is my sequence, which is going to reveal what a and d are for me, right? And the question is, what is the n then? What is the n then? Okay, so what's a in this case? What's a in this case? A is the first, by definition, a is the first term, right? A is 5. So a is 5. And what's d? The common difference is 2. Correct? So the question becomes, so again, remember, this is the sum of the first n terms of any arithmetic sequence, in particular this, which is an arithmetic sequence. That thing is going to be this all the time, right? In this case, a is 5 and d is 2. So the question becomes, which question I'm talking about? This question, right? Which is equivalent to this in purple. And now I'm going to try to simplify it. The question becomes, we want to find the n, the number of terms that I should add, such that, st for such that, Sn, right? Sn should be 572. And what's Sn? It's this guy, correct? So such that n over 2 times a, and what's a? A is 5. So 2 times 5 plus n minus 1 times d, d is 2, right? So this guy, which is Sn, should be 572. Should be 572. Correct? So the question is to find this n that does this job. So this is a quadratic equation, right? You see n times that n is going to be n squared. Anyway, so this is a quadratic equation which we can use quadratic formula for it, or you can just use any intuition that you might have. Okay, so that sequence type question boils down to a level where we can handle, right? Okay, so that is, I want to find n so that, let's solve this. So n over 2 times 10, right? 10 plus 2n minus 2 is equal to 572, which means what? N times 5, I'm gonna distribute the multiplication over addition. So n over 2 times 10 is n times 5, so 5n, plus, how much is this? N over 2 times 2n. This is n squared. And n over 2 times negative 2 is negative n, is equal to 572. Okay. Alright, so this is n squared plus 4n minus 572 equals 0. Alright. And here, if you use quadratic equation, you try to find b squared minus 4ac, the discriminant of the polynomial n squared plus 4n minus 572. You do it and so on. I'm gonna leave it as an exercise. So use quadratic formula. So QF for quadratic formula if you want. And you should get n minus 22 times n plus 26 equals 0. So you factor it. And this is equivalent to saying that n is 22 or n is negative 26. Correct? Well, which one should we choose? Apparently I have two choices. Can I choose any of the two? Well, certainly I cannot choose any of the two. What's our context? What does n mean? What does n mean? N means the number of terms that I should add to get that 572. So the number of terms of that sequence. So certainly n should be a number that's positive, right? So since n cannot be negative, being the number of terms, right? It must be, so it must be the 22, not the negative 26. The 20 plus 22. Okay. So long story short, we should add 22 terms of this sequence to get to this number. Okay. So in conclusion, we must, if we add the first 22 terms of the sequence, which is the subsequence of odd numbers, the sequence of odd numbers. So we, if we add the first 22 terms of the sequence, we get S22 to be that number 572. Okay. All right. So this is the end of this section.